Welcome to the second lecture of CS372. And this course is about artificial intelligence for reasoning, planning, and decision making. We all know large language models have been very successful. However, we also understand the current LLMs suffer from some shortcomings. Especially like Yang Lucan has mentioning, the current LLMs have some problems with reasoning, planning, and doesn't have word model, and finally does not have persistent memory. So therefore, Lucan argues LLMs cannot lead to general intelligence. But we consider a little bit different. We say, well, LLM, if we consider, is similar to humans' unconsciousness. Then unconsciousness itself is reflexive. It's automatic, but it actually operates the most important functions of human body, including heartbeat, muscle kind of control, and the metabolism, and so on and so forth. So human become intelligent is founded on unconsciousness. Then on a conscious level, we are dealing with the real world scenarios, and we do adaptation, we do learning. And eventually, when our learn matters become repetitive, become reflexive, and actually they are kind of written into our unconsciousness. One example is we started as a child, we learn how to walk. When we learn walking, we need to balance our body. But once we habitually can balance our body when we walk or bike, we actually don't have this kind of conscious awareness when we are driving, walking, about really balancing our physical conditions. It's already kind of reflexive, automatic. So therefore, when some researchers are arguing saying, well, a child of 4 years old can recognize an object with just a few shot learning, and I really consider the abstract level was not really kind of considered well, because a child was not born with a blank slate. A child was born with a robust unconsciousness, and just similar to LLMs, right? We have LLMs, but to be able to have LLMs to do reasoning, planning, and the decision making, we should build something upon the current LLMs. So my personal position is I can agree LLMs is not sufficient to lead to AGI, but I will argue large language models are necessary. They are necessary components to lead to AGI. This course is to define what are those components and how to build those components. And today we start to try to answer the first question: why multi-LLM agent collaboration is necessary to lead to artificial general intelligence. And we break down today's lecture into two parts. First of all, we'd like to cover selective aphorisms to support our treaty. And then we have a brief introduction into soccer things. And soccer things is basically we have multiple LLM together and try to debate on a subject. And the debate is not as easy as we think, as we will illustrate the details shortly. Okay, good. So the first of all, we like to see the current approaches of multi-agent systems. We have heard about this mixture of experts, right? For a long time, people done this. The major idea was, suppose you have one classifier which accuracy is, let's say, 50%. Actually means really bad, right? If you have this binary classifier, 50% is like a coin toss. But they say, well, if I have multiple ones, then you can mask errors. Redundancy can mask errors. So you see the equation on top. E means error rate. Error rate, and I have this star here, means how many experts do I have. If I have 10, right, so simply if I have 10, then everyone make 50% mistakes. Suppose they make independent mistakes. And hopefully using this formula, I would reduce error to 0.1%. Well, that'd be fantastic. That's the gist behind this mixture of experts. But in reality, this never happens, right? If this happens, we don't have machine learning courses today. You just build whatever, 50% coin toss, hey, you're home free. But not really that easy. And so the mixture answer is actually not working that well. Maybe you can get some really small mileage of improvement, but when the possible answers it's just not binary. When you have 10 possible answers, or you have this kind of open scenario like generative AI, we can pretty much forget about it. But only thing it can do, which we will come back to revisit, was probably to handle hallucination a little bit. And this will be Aphorism 4, we will cover shortly. But so mixture expert is already implemented by LLM models, right? GPT-4, in the beginning, they claim, wow, the difference between GPT-4 and GPT-3 is now we have maybe 8 GPT-3 is running in parallel in the background. So when you submit your query, maybe submitting, we can submit into 2, and then they can negotiate with each other, give you the final answer. And Gemini, I think at one point they said they have 16, right? Or 16 if you have this formula. Wow, Gemini should be very popular today, but actually not. The second way to do it is kind of a sequential chain. And again, most of people heard about chain of thought. Basically, a math problem, let's say I have 5 eggs in the refrigerator, and I need to buy more because kind of short of egg situation. I buy 2 dozens, and how many do I have? So the chain of thought would say, okay, I don't know how to do it, but I'm going to thinking about how I'm going to decompose the problem. Okay, 3 plus a dozen is 12, and times 2. Okay, I'm going to do the first step, maybe multiply, then I do an add, right? So this is trivial. However, as I mentioned last time, this is kind of speculative reasoning or adaptive reasoning. There are many chains to solve the same problem. Unless you can get all different chains figured out, then you solve the problem using multiple sequences, and at the end you do a voting. Otherwise, this kind of speculative reasoning may not yield high results. So when you read the papers, a lot of papers out there using chain of thought, you say, well, the problem was accuracy was like the egg problem, accuracy was 50%. Now I get this 70%. Wow, I'm so happy. Frankly speaking, if you do something serious with 70% accuracy, you might as well, right? You're probably in deep trouble. So I have not been fully convinced for this chain of thought. And chain of thought also, it's kind of only one agent get involved, one single LLM thread get involved. You don't really have multiple instances. Why do we need to have at least multiple instances, even you only use one, for example, one GPT, you don't use another cloud or whatever, just one product. Why multiple instances would be better than just single instances when you try to do chain of thought? And the reason was sort of like touched upon last time. One was your context buffer eventually get polluted, right? So there was an interesting talk about last quarter. There was a theoretical talk, basically. The paper title was Pencil, or last time I alluded to be Eraser. And the professor did a lot of proofs. Eventually, the conclusion was, if you have chain of thought, multiple steps, so you want to make sure after the first step, you clean up your mess. You only preserve the result of the first step. Then you go into the second step. So then the second step, you wouldn't get polluted by the previous context. It seems like a very naive idea, right? I mean, in real world, when you do planning, not just doing this egg computation, the second step may depend on context of the first step, right? So this method looks intuitive, but it is not universally practical. So chain of thought is good for simple questions and improving results from, let's say, 50% to 70% accuracy, but I'm not convinced it is for the major league. And the self-critique, this became popular after, maybe I was wrong, but maybe became popular after DeepSeek, because then we see this kind of self-evaluation in the process on the screen. And right away, GPT-4 and 4.0 and Cloud 3.7 implement the same thing. So we can probably kind of guess it's not very challenging to do this kind of validate rethink. Otherwise, they just took them just 1 week to follow, right? Other people did it. Oh, okay, we did it. We did it too. And they didn't do it before. Was saying, wow, if I do it, my serving cost will be double or triple. So therefore, I want to conserve my serving cost, inference cost. And DeepSeek did it. Oh, the result is better. People hype about the situation. Then they just follow within just a few days. So definitely there was no major breakthrough under the cover. But the challenge is, again, like I said, a single thread to validate itself. And under the situation, you have this context sink or context loss situation, and plus the fundamental theory of Gödel limitations. An agent, in formal reasoning, one agent just cannot self-inspect itself with high accuracy. And the considered human being, right? If you want myself to evaluate whether I gave a good lecture or not, I will come up with different kind of excuses. My ego will be in place. So my self-evaluation will never be very accurate. Everybody was probably thinking about yourself to be too good or too bad. So we need a mirror. We need other agents independently to give us feedback, and we have more objective perspective. I'm saying more, I'm not saying absolute objectivity. This is another aphorism we talk about. Objectivity is a hard problem in philosophy and also in practice. There's no absolute objectivity. Okay, then the debate framework, and which a similar one is an expert panel. Like say I have this patient comes in, a general physician really don't know, a family physician cannot detect exactly what kind of diseases the person has. Maybe the physician refer the patient to a specialist or multiple specialists, and maybe they can form a panel to do joint diagnosis. There are many situations like brainstorming sessions like that. And workflow is critical because if you want to do something long-lived, rather than, okay, I give you some question, you give me a response, and I go away. Let's say last time I gave the example of travel arrangement. You have multiple cities you need to travel, you need to book hotel, maybe transportation locally and airplanes, right? And you could have some situation you need to do compensation or rollback. That's kind of transaction properties need to be preserved. And this whole process will run for weeks, if not years. And the supply chain management is definitely a huge one. And if you can put AI into the current supply chain management, that'll be golden. At least the current supply chain management is just a whole bunch of transactions and databases. And there's no places you can see why you do that, why you do this. And when there is an interruption, right? Interruption of certain things, and when you need to alter your transaction doing rollback, there should be a discussion somewhere. And the decision made by your workflow system should tell you, oh, there's an alert, and this is what I'm going to do, and these are the reasons, please make a decision. Or just a black box saying, oh, your computer get invaded, good luck, right? That's not going to be very helpful. So those are the potential things we think we can leverage multi-agent to improve. And hopefully this will be leading to AGI. And AGI is not just having a better LLM to give you better answers. And at the end of this talk, this discussion, I would say, the more important thing is you want to be able to generalize beyond your priors. Right now we are saying, oh, we have the training data sitting there, billions of documents, and even trillions of documents. And then we say, we want to be able to innovate, right? Everybody wants to innovate, come up with good ideas, but can ChatGPT innovate out of the current priors? How can you make GPT innovate? And that should be a feature of AGI. If AGI doesn't have that feature, then why we call superintelligence? There's no way to do that, right? No way to say that. So currently, let's just focus on debate first. Then we will expand this multi-agent eventually to do other things. And the final topic of this lecture will be going to workflow, right? How do we model real-world applications virtually automatically? And the first aphorism out of the 12 is, basically, if you work with LLM and you get a bad answer, let's say I get something hallucination, I couldn't understand the answer, or
either the answer is wrong or the answer is kind of really far-fetching. So in those kind of situations, there may be two reasons. One was the data, the training data was just not adequate. So there was no knowledge to answer your question. And the second one everybody knows, that's hallucination. And how do you tell whether the system is hallucinating or it just cannot answer your question without the data? And that's an interesting fine-tuning project maybe you can discover. And one student was working on just looking at the buffer and the probability on the top. And the conjecture is, if the entropy is very high, predicting different nest tokens, but there are many, many possibilities, and the likelihood is you have so many different choices, hallucination probability will be very high. Suppose you have low entropy means, okay, I'm pretty certain this nest token, right, like chip, you put in chip, and well, I know this potato chip based on the context, or this could be a kind of computer chip. So you are pretty certain about it, then your prediction, the probability distribution will be low in entropy. So that could be a hint, but not necessary, maybe high in precision, but low in recall or vice versa, okay? So that's a project that definitely involves more investigation, but let's say it's really a hallucination. How can we deal with that? And the key thing is we just have to refine the query to be more accurate or more well-defined. And there are two things need to be done from the user side. The user may have provided something without specificities, or the user did not provide the contextual information. They say, oh, give me the best pizza restaurants in town, but you didn't say which town, right? Of course, you get some arbitrary results. And so the interesting thing about this multi-agent at this point will be, even you don't have multi-agent, the agent should have a dialogue with you to refine your question, like just like query refinement, saying, oh, I'm missing time, I'm missing location. So this shouldn't be too hard for ordinary queries because who, where, when, what, how, right? You can say, oh, are you asking this and that? And you don't have this information, that information, I have to query you. So internally, those LLMs, especially ChatGPT, they should have a lot of templates sitting there. So when you ask a question about restaurant, you will say, okay, you ask this type of question, I'm going to use restaurant query template. And that template has 7 inputs. If you don't give me those inputs, I just keep on asking you until you stop, and I will give you the best answers. Right? That's pretty much the way currently people are doing. This was one of the projects involved with Professor Monica Lam. He was doing virtual assistant. And that virtual assistant was basically, the mission was, how do you translate human natural language into programming language? Because when we ask a question to Alexa, whatever, and basically if you can parse the natural language into API calls to call Yelp or call different APIs, and they provide information back. Then you say, okay, you have a template, this is the question, this is the answer you should supposed to give it to me. And that kind of well-defined APIs will be able to, like a template, to help LLM to give you better answers. So again, this process is just give you, just force the user to sequence the query in a much better fashion and also provide robust context. Okay. This is like, this doctor example will be coming up many times in this course. So it's like you go to see a physician, the physician will ask you, like next week I have an appointment in Palo Alto Medical Foundation. So before the appointment, they gave me a list saying, oh, what kind of symptom do you have? Click, click, click. And really, I'm not precise about, because interesting enough, they only allow you to click on one major symptom and say, oh, you have a problem with what? Rash? You problem with diarrhea? I say I have multiple major symptoms, but no, you just cannot, you can only enter one. After you enter one, they say, oh, what are your sub-symptoms? Do you have a headache and so on and so forth? Okay, after you have entered everything, then you go to see a doctor, and doctor will say, based on whatever you have given me, I have 20 possible diseases. You may have 20 possible diseases. So I have to ask you further questions to narrow down. So this is a process a little bit like reinforcement learning, right? The reward is accurate diagnosis, but in the process, I'm going to ask you more questions. Each question, I like to get the maximum information from the patient, which is the reward. If I get information from you, let's say I ask you, do you have headache? If you say no, I didn't get any reward. If I say, wow, do you have fever? Yes, oh, you get reward. So this training process can be done through a reinforcement learning. And the doctor established the kind of temporal patterns of symptom onset. But this was actually not well done by physicians in any measure, because most of the time when you gain to see a doctor, doctor say, do you have headache? Is your headache severe? What will be the consequence? You say, oh, no, I'm very serious. No, of course, everybody faking. Oh, it's just too bad. So I have to be treated, whatever, right? So you don't get really good answers. But there are some refined things like when you have headache, do you vomiting at the same time? Is your headache getting worse or getting better? Or multiple times or with kind of continuous duration? Those are much more refined kind of questions. Unfortunately, my daughter seldom asks me those kind of things. But then once the doctor collecting all information is still kind of confusing, the doctor will say, maybe you should go out to do a blood draw or chest x-ray and so on and so forth, right? So just getting more and more information, and finally doctor may just give up saying, oh, I'm just a general physician, so you should go to see dermatologist or eye doctor. So this is kind of process of inquiring more information from the user, and so therefore the diagnosis can be done accurately. Nothing different from LLM, right? If you don't do all these processes, you just come in, a patient could just come in and say, oh, this is all my symptoms. Then you don't need to have hospital. You just, on internet, you type in your symptoms, boom, the prescription can send to you. It's just not there. Okay, so the merit of the first one is just very rudimental. It's all about the quality of questions, stupid. That was the initial aphorism I put forth, but GPT suggests me to remove stupid. So that was it. The second one is fluid intelligence through debate or discussion. So like I said, if you have one doctor, just one doctor probing you, you may have initial assessment. But if you have two LLM doctors, one of our paper simulating, you have two doctors debate with each other. It's very interesting. The first doctor saying, you ask the first doctor predicting, let's say 3. You force the second doctor, you can say predicting 4 or 5. This has some interesting reasons behind it. And I will talk about later, but let's say Dr. A present 3. There are two ways you turn Dr. B to oppose Dr. A. One way was just say, oh yeah, okay, you just openly, you present your predictions, then we can start debate. The other way is you can force opposition. You say, Dr. B, just criticize Dr. A. Play devil's advocate, right? You just counter-argue all the arguments made by Dr. A, and hopefully you can have your own diagnosis, the debate will just get started. And then, yeah, this iteratively can be performed. And this is interesting, but there's a major problem. The major problem is if you have two LLMs, they are equally competent, then very competent, so you are okay. If you have two really mediocre LLMs, they lacking medical knowledge, then you're going nowhere, right? So the feeling is post GPT-4, we are there.
So in summary, the merits of debate are the following. First of all, we need to understand an LLM was trained to have this kind of maximum likelihood prediction for the next token. What do we mean by maximum likelihood? If the training data, majority of the training data consider the next token to be, let's say, chip, potato, should be potato rather than computer, then majority will win. And so the outcome is the most popular answer, not really the most accurate answer. We need to overcome this particular trap, and this is the major causes of bias. Suppose simply we have the second agent saying, okay, the first agent, whatever default answer you provide, and the second agent is going to just play devil's advocate, saying, no, I against you, and these are my reasons and my positions. And that'll be really helpful after a few rounds. Basically, we can unearth multiple perspectives for a particular subject. So let me give you an example of my own experience about this majority voting. And basically, web search is sort of like a majority ranking, right? Most of websites point to a particular website, then that website will be ranked higher. And I tried once, I say, what's the benefit of having high cholesterol? And I inspect the top 20 results. All of them are about the downsides of having high cholesterol. High cholesterol is being high and it's really harmful for your health. The reason is, well, most people, when they talk about high cholesterol, they talk about the damages. There's no one basically talking about benefits. I started to conduct multi-agent debate research about 2 years and a half ago. And initially, I put together a white paper, submit to my senior colleagues for review. And one colleague saying, well, I was intrigued by your debate setting, but then I was disappointed. The reason was because then I found out two agents are too friendly to each other. They kind of completing each other's sentences. And this was a very good observation. And the suggestion actually inspired me to come up with this qualitative linguistic behavior called contentiousness. If two agents debate with each other with high contentiousness, then they are able to unearth various perspectives on a subject matter. And in a very simple setting is you can ask agent A to just output its opinion based on maximum likelihood, and agent B play the devil's advocate, try to opposing agent A and come up with his reasons. This setting seemed to be reasonable in the beginning of debate because we want to unearth various perspectives and to mitigate biases. But then you cannot continue with extremely high contentiousness, otherwise the participants would repeat the same arguments over and over again without acknowledging each other's strength. So when you consider the debate quality or the reasoning quality is not as good, then you have to start to qualitatively lower down the contentious level to something like conciliatory. Now, conciliatory means they start to acknowledge each other's strength and making some reasonable concessions. And finally, when mutual information is not improving, you say, well, this is time to conclude your debate and put together an audible trail of reasoning during the whole process. And this final report is valuable for human in the loop to make final decisions. And it's not possible for agents to come up with a perfect final decision for human being, but this process is essential for making more objective decision making. And this picture depicts a soccer things debate setting. We have human in the middle as a moderator, and we have two debaters. As we mentioned earlier, the two debaters, if they are post GPT-4, they are competent enough to conduct productive debates. Then we have several judge agents sitting on the side. And later we will talk about what the judges are doing. But basically the judges evaluate the argument quality. And when the argument quality or reasonableness is not there, and they will suggest the moderator to complete the debate. And decision makers sitting in the middle, human in the loop, and reading the transcript of the entire debate, including reasons, including different perspectives, to make an overall good decision. Next, we start to talk about the Aphorism 3. This is about hallucination, how to mitigate hallucination. First of all, the causes of hallucination, typically one is the large language model in the training data, they do not have the knowledge to answer a particular question, right? And the second reason is due to the imprecision of the query. A user asks a question without specifying details, did not provide sufficient context, and the answer will be very, very loose. And the This is still an active research topic, how to detect hallucination, whether it's because lack of data or because of stochastic scenario or the user query is inadequate. And we don't cover this right now. But what we will be covering is the hallucination itself in a debate scenario would just automatically, magically disappear. And let's first consider analogy. So suppose you had a nightmare. Do you ever have the same nightmare, exactly the same scene and sequence in your lifetime? And in my experience, I may have sort of like the similar dreams. Let's say I failed passing the qualified exams of my PhD degree, but the narratives or stories are different. So I never have exactly the same repetitive hallucination in my life. And hallucination is really a stochastic kind of process and depends on the contextual situation and also sort of like randomness in this next token prediction situation. And let's don't get into the details yet, but let's say because this non-repetitive nature of hallucination, when two agents start to challenge each other, there are two consequences. Number one, if the hallucination itself is lacking logic, and the second agent, the opposing agent, will pick it apart very quickly. And secondly, when the debate continues happening, the evolving context progressively constrains the hallucination space. So there are two ways you can consider the space get constrained. One is the context get richer and richer. Not only we have better breadth, but also we have better depth, right? And the second situation is once your context is different, it's even better, it's richer. And in probability, there's no way to come up with exactly the same hallucination. So naturally, and hallucination dissipates. And just like I said, so the causes, real causes of a particular hallucination, we still need to investigate, but we don't really need to worry about two agents. They will enforce each other's hallucination. Although I don't have the proof, but this aphorism hopefully provides a kind of reasonable intuition and insight. The next aphorism, critical thinking requires more than one Socrates. The key spirit has been covered. Basically, we have two LLMs, and we can evade the trap of maximum likelihood. And the debate can bring up better breadth and also better depth. Okay, and there's another subtle point is about self-validation. And self-validation was first sort of like implemented by DeepSeek. And when you use DeepSeek, you can see DeepSeek is kind of talking to itself. And we call that rethink, evaluate loop, right? You can do it multiple times. But I think DeepSeek overlooks the Gödel incompleteness theorem. The theorem basically saying in a formal system, you conduct reasoning. And this reasoning thread cannot actually evaluate its own completeness. So in other words, like human, we inspect ourselves, we self-evaluate ourselves because our blind spot, and also maybe we are a little bit emotional and self-protective, and it's not adequate for us to evaluate ourselves. It requires an independent third party to be able to do independent evaluation. And likewise, and self-validation is also in the same situation, and the cross-validation is the right solution. Now again to this very interesting aphorism, LLMs is actually not really a black box. Think about it this way. We so far consider LLM is just predicting the next token, and we have no idea what's going on under the cover. I remember 2 years ago when GPT-4 was launched, and the Microsoft tech lead came to Stanford to give a talk. And on the one hand, he was talking about the superior performance of OpenAI's GPT-4. And he also expressed they just couldn't see the inside in the box. So therefore, Sebastian the lead saying, well, LLM is just a black box. But thinking about LLM is trained by billions of documents. And each document is to fulfill a human's objectives and using linguistic patterns and linguistic sort of like behaviors, right? So let's say I want to complete uh, a research article. I have objectives to fulfill. I need to articulate my motivation, the methods, and through experiments, I conduct thorough kind of evaluations. So there are certain kind of requirements for a paper to be accepted. And similarly, you write a fiction, you hope the plots can be very attractive. We write love letters to our loved ones, and for sure, we want the letter to be very impressive and convincing. And if we consider this is true, then there is a possibility we can actually modulate linguistic behaviors. And rather than just thinking about the LLM, just keep on predicting the next token. Let's now use an example to illustrate. We talk about contentiousness. And so when I conduct my experiments with two LLM to debate with each other, I generate a few debates and ask LLM to argue with each other with 5 different levels of contentiousness. And zero point 0.0 at the bottom of the table means low contentiousness, be agreeable. And 0.9 means highly contentious, right? So I only provide this real number to LLMs. I say, okay, zero, your intensity can be from 0 to 1, and 0 means what, and 9 means very high, extremely high contentiousness. And then I say, go ahead, generating your debate. And after a few subjects of debate, after a few rounds for each debate, and I just collected all the materials and I sent to large language models to say, can you now analyze what have you done? What kind of linguistic behaviors and patterns you have employed to try to mimic a certain linguistic behavior in different levels of contentiousness. And this is a table generated by GPT-4. I was very surprised. And basically it says under different linguistic behavior, different intensity levels, the tone, emphasis, and languages used by GPT-4 to generate these narratives will be different. For example, when contentious is very high, the tone is most confrontational. And that's, for example, if the other side saying, oh, I think this is beneficial, then the tone is saying, yeah, it's beneficial maybe, but it's very costly. Or it can violate social objectives or maybe unethical. And the language, the last column, well, you keep on strongly saying not allowed or unacceptable, using those strong language to object. And in the middle columns, you're in, well, just a position, just keep on highlighting the risks and the downsides. And then when the contentious level is lower, then the attitude will be much more amiable. And it was really a surprise through this kind of self-supervised learning. And we learned that you can actually changing the linguistic behavior or emulate linguistic behaviors of large language models. The second study of our linguistic behavior modeling was we tried to map linguistic behavior on top of basic emotions. What is basic emotion we can define shortly. And the intuition is a linguistic behavior such as writing a love letter consists of emotions including love, maybe some sort of sadness because two loved ones cannot get together. And we borrow Robert Plutchik's wheel of emotion as the basic. The wheel basically consists of 8 basic emotions. And basic emotions are the emotion coming from our unconsciousness, unfiltered. And on the contrary, complex emotions such as regret involves consciousness processing, right? We have to have memory, accessing the past, projecting the future. Then we thought we probably shouldn't have done this and that. And personally, I incline to model complex emotion as linguistic behavior. This is meant to be performed. A shortcoming about this basic will is the opposite side of a will, like submission versus contempt. They are not really antonyms in our languages. Or you look at remorse and love. The antonym in language, the opposite side of love should be hate. So I spend a lot of time to remodel the wills and using linguistic antonym as a basis. And this figure shows our behavior emotion analysis model, abbreviated to BEAM, being. Each row depicts an emotion spectrum with negatives on the left-hand side and positive on the right-hand side. And the middle emotion, we can just use a real number to multiply to scale in between. And this is very convenient. First of all, it's a continuous spectrum. And because we can just use a multiplier, we can have very fine-grained control. Otherwise, to come up with so many different emotional words in between -1 and the +1 is extremely challenging. And we conducted preliminary experiments by having a scene of garden and a lady sitting in a scene. And we used the second row of emotion and asked ChatGPT to present different emotions in the image. And so from sadness all the way to joy and happy, and these 6 images displayed here are really doing their jobs. And on the top left-hand side, you see a lady extremely happy, and the gardening background, the scenery is also very lovely. And all the way to the bottom right, and the lady is not so happy, remorse, or very sad. And also the scene, the garden is kind of very dark and expressing sadness at the same time. Our next aphorism is about truth and objectivity. And these are two kind of philosophical questions. And first of all, many consider there is seldom truth in this universe. And we may have some mathematical treaties like geometry, and we may have some physics laws. Those are maybe universal truths, but in a lot of scenarios, we have many different opinions, and they are not really objective but subjective. And objectivity in philosophy is a really hard problem because if an individual get involved in any measurement, right? This is like second law of thermodynamics. If we try to gauge entropy of a system by opening the container and insert an instrument, and the measurement will not be accurate because you are perturbing the system. Likewise, if we are situated in a situation, try to be objective, and we ourselves try to measure or try to behave objectively, it's just virtually impossible. Okay, so that gives us an important direction. That means when we try to ask GPT multi-agents to do a conversation or try to collaborate, our aim is not really getting some truth. Our aim is to gauge the process has been conducted reasonably, right? If the process has been proven to be reasonable, then we can present all the arguments again to the human in the loop to make final decisions. And here I would like to use 2 examples to illustrate the ground truth may not actually exist in many situations. The first example is about healthcare. In the healthcare domain, we do diagnosis. And as I presented earlier, and most of the physicians will perform diagnosis by doing a sequence of symptom checking, right? So the doctor may ask you, do you have a headache, and do you have fever, and so on and so forth. By learning your existing symptoms, and the doctor may say, well, you may have this disease or that diseases. If information is considered not sufficient, the doctor may ask you to do some lab tests to try to mitigate or reduce uncertainty. And even further, the doctor may refer you to see some specialists. So although the process has been heavily regulated and the doctors have been well trained, unfortunately, the CDC data shows there are about 10% of the diagnosis in the history was actually misdiagnosis. And there was an intensive study performed by Johns Hopkins and published in 2023. And the 10% of the medical records showing the diagnosis was not accurate. And since they have this longevity data, and the way they found out diagnosis was inaccurate was eventually if the patient passed away, they probably know the diagnosis was a mistake. Okay, so in our machine learning practice in the past, you can read many articles. We pretty much just trust the CDC data to say those could be a set of ground truth, right? Then we train our classifier using supervised learning to do diagnosis for unseen patients. And this is definitely a horrible thing, because if we have misdiagnosis in the training data, and the trend predictor will continue to propagate those mistakes. And this is never-ending cycle. And so how to mitigate this problem? And one of the chapters in the book showing using debate is very helpful. And the next time we will be discussing, instead of just qualitatively asking two agents to be contentiousness or to be conciliatory, and we can use information theory metrics to do quantitative kind of adjustments. But this is one example about even in the real world, we seldom see ground truth. And another example is easy understood. You look at this, a lot of political issues, and you have left and the right wings, and they just cannot have agreement, right? And there's a classical data set which we used in our experiments. It's a data set collected multiple articles. A set is about Republican scandals. The other set is about Democrat scandals. And they recruited about 1,000 annotators. Those annotators were well screened. They were kind of experienced annotator on Amazon Mechanical Turks, and they went through some interviews. Okay, then the annotator were divided into two groups. One is Republican pro, and the other side is Democrat pro. So then they were given the articles including Republican scandal and Democrat scandal, and each article will be annotated by both Republican and Democrat pros. So the end result, after we tally the statistics, and you can see there is a kind of one scale bias. So here scale means we measure the biases having extremely bias, medium bias, and the negative bias, and then we have positive bias. And the middle one is called neutral, right? And Republicans tend to rate Republican scandals to be negative biased. And Democrats will read those Republican scandals to be positive biased or neutral, and vice versa. So this definitely shows the ground truth when we don't ask those annotators whether you are Republican or Democrats, and without knowing their identity, we're just getting an annotation which is itself already biased, right? So how can we, based on training data, to kind of training a impartial classifier? This is just very challenging. So without getting into details, and we using these productive dialogues between agents, and we come up with some decisions which sit right in between the Republican bias and Democrat bias. But since there's not really ground truth in this situation, and our results sitting in the middle, and they really cannot justify the debate at this situation, it's very neutral. It's just basically showing when you have debate, allowing multi-agents to have different perspectives. Hopefully, again, different perspective can be unearthed.
And finally, this is coming back to this evaluation of logic or reasoning. And we formulated this about 2 years ago, and it's reasonably cited. And so basically we say, since we don't know your argument, when you argue against something or for something, we don't know whether your argument is true or false. What we can do is we want to measure your argument, whether your argument itself is reasonable, right? So we use the Socratic method, which has 7 different methods. We map those methods to one of the reasoning paradigms, inductive, deductive, and adaptive. And then each one of them you can map to existing tools in statistics or machine learning. And deductive reasoning is pretty much like prologue, right? It's a formal reasoning. A entails B, B entails C, so A entails C. Then the inductive learning is basically probabilistic, like machine learning. A dog has 4 legs, but it doesn't know all dogs has 4 legs. Unfortunately, there are some dogs missing 1 leg, but in general, that's true. That's inductive reasoning. And this is chain of thought, which I am not using for this evaluation. And this is an example, right? After a debate, suppose this is a debate topic. Should advertising aimed at children be regulated? And one side saying yes, one side saying no. And then after debate, this document is easy to formulate because each side has the objective statement, right? The first side saying, I agree, right? The next side say, I don't agree. So your goal statement is right there, very precise. And you have debated for multiple iterations. At the end, I ask you to summarize your supporting arguments, supporting reasons. And then I use this Socratic method to evaluate your reason against the goal. That's called reason to your goal. That's sort of like entailment. Evaluate the quality of that particular argument. And in terms of 2 or 3 things. One is there evidence, right? Is evidence sufficient? Or if the evidence is credible. So those 2 things we can obtain from Google, for example, and from some other sources. And for this particular example, for the 3 arguments, I can give scores: validative argument and the credibility of source. And once I've obtained those, I can tally the score for this, the pro side, and also a score for the con side. And it works okay. And when I swap positive and negative, and you actually give me the same winner rather than saying, oh, I'm going to get confused. So far, I consider this method to be quite robust to kind of gauging reasonableness. And for sure, if you get something like, after debate for 2 or 3 rounds, you get this 60% validity in the argument, and or your argument is repeating itself, then you say stop. You guys are just, you have to kind of, you guys may be fatigued or something, you just have to stop right there. So qualitatively, with this quantitative support, it's a reasonable approach. Of course, if you come up with even better approach, it'd be fantastic.
In the remaining time, we are going to cover the 7th aphorism, which is polydisciplinary. And this was given by Eric Howes, Microsoft CSO, about 2 years ago in a Turing lecture. And basically he was saying, well, when we train large language models, and we have billions of documents being processed, but transformer really doesn't know which discipline a document belongs to. So as a human, we know this piece of document is about literature, that piece of document is physics, and maybe computer science, but LLM doesn't know. So in fact, when LLM trains with all those articles and generating this transformer representation, this representation is without domain boundaries. Let's compare the term polydisciplinary with the traditional terms of multidisciplinary and interdisciplinary. And multidisciplinary means we have a project with students from different domain or different departments. They collaborate together. It's less effective than one person who studies multiple domains. And this person can synthesize information from multiple domains in their neurons. And the polydisciplinary is even more stunning. Basically, you have this big sphere, and all your neurons have different knowledge together, and you don't even know their boundaries, which is precisely how large language models were trained. And this provides ample opportunity to discover new knowledge, which I would get into slightly detail shortly. But during the presentation of Sebastian, which we mentioned 2 years ago, and he presented the outstanding performance of GPT-4. And in this performance diagram, it's interesting to see two different exams. One is on the right-hand side, this red circles GRE verbal. And you can see the legend, and the blue color means GPT 3.5, and the light green is GPT-4 without vision data, without images. And then you have GPT-4 with multimodality. And the right-hand side, this red rectangle shows when you have GPT with image data and test together, the GRE verbal, they can score about 3% better than a GPT-4 version without vision data. And this can intuitively be understood because you may have image of cat annotated by multiple languages. So image may serve the role of transfer learning to a certain degree. But this left-hand side, GRE quantitative, is really surprising because if you combine images with text, and somehow you can improve the score for math problems, which I just cannot understand. So this remains to be a myth. And at the same time, this seems to be the similar story of saying, well, when you have this kind of polydisciplinary situation, it may be able to synthesize a new kind of representation or new knowledge, but we may not be able to interpret. So knowledge can be divided into 4 different quadrants, but simply say we have something we say we know, that's probably 1% of the world knowledge, and then maybe another 1% is we know, we don't know. So the exam questions we failed means those are the things we don't know. But the vast majority of this universe belongs to unknown. We don't even know, understand the knowledge itself. So in that unknown situation, and we have even no idea how to ask a question. So this picture depicts a scenario. Every year we give out Nobel Prizes, and you have this, the past winner will be sitting on the podium, and the new winner will come to give a talk. And suppose I'm 10 years old, I'm sitting in the middle, and they give me a chance to question those Nobel laureates. And there's no way I can ask intelligent questions in this situation. I could probably just embarrass myself from the beginning to the end. And I might as well just standing there or sitting there to listen to their discussion. So yes, polydisciplinary is the rich ground for doing innovation, finding new ideas, undiscovered knowledge, unknown. But how to harvest from this very, very rich ground remains to be very challenging. I have two experiences which GPT or cloud provide me a new treatise or information and for me to broaden my perspectives. But a probably easier route is I tried it about 2 weeks ago was after I pretty much finishing this MACI book, I asked GPT to say, now, can you just give me the outline of rewriting this book without any computer science knowledge? And you can use biology, chemistry, and so on and so forth. And the proposed outline was quite surprising and quite interesting. And that could be an interesting project for bio or chemistry major or student to embark on. So to summarize today's lecture, we covered 7 out of 12 aphorisms. Those are not theories, but those are insights I personally obtained and also share with other researchers. And some people argue debate may be very costly, but next time we will get into the cost, because the cost of this kind of debate or self-validation is linear growth compared to the training data volume growth. That's an exponential growth of cost. And since we are already willing to spend so much money on GPUs, and this shouldn't be an argument about we run this kind of self-validation or debate for maybe 10 or 20 iterations, right? It's just a kind of linear growth. Okay, so let's revisit these aphorisms and wrap up with the rest of aphorisms in 2 lectures. And see you next time.